Let's go over the worksheet where I have both ionic and covalent compounds. This particular one is naming the ionic compounds. One thing you'll want to remember with naming these is that there is nothing in the name that says how many atoms there are. So if I look over here, I have two atoms, two ions, and I'm simply going to name those ions. The first one is just the name of the element, which is sodium. The second one is oxygen, but we only write the root word and we add "ide." So that would be sodium oxide. Over here, the first one is magnesium, and we have fluorine, and its root word is fluoride. So fairly simple. We have aluminum, and then that is bromine, and it would be bromide. So for the names of these, grab a periodic table. They really should not be hard to name the ionic compounds. For writing the formulas of ionic compounds, you have to know the charges. And remember that the charge, the name of the charge, is called the oxidation number, and that is written as a superscript with the charge. So for number 1 here, we have sodium, and sulfide is sulfur. So I look at the periodic table, and sodium is in group 1, so it has an oxidation number of 1. Sulfur is in group 2, so it has an oxidation number of 2 negative. And we're technically supposed to write the number and then the sign. I'm not going to worry too much about it in physical science. And then we do a little crisscross here where the 2 comes down and the 1 comes down, but we don't actually write the 1. So our answer is just Na2S. For a different one, let's try, let's just do aluminum oxide. So number 2, aluminum is in group 13 or 3A, so it's 3 plus. Oxygen is 2 minus, so we're going to have to do a total crisscross here, where we have the 3 come down on the 2. And please remember that the subscripts are the number of atoms. They have nothing, they have nothing to do with the charge. So there should be no positives or negatives, and they are subscripts. Okay. Let's do magnesium phosphide. So this is number 6. Magnesium is in group 2, so it has an oxidation number of 2 plus. Phosphide is in group 15, so it has 5 valence electrons and will gain 5. So its oxidation number is -3. And we do a crisscross where the 2 comes down from magnesium, 3 comes down from phosphorus. We have Mg3P2, and that's our formula. If you have, I'm looking to see, yes, let's do number 5. This is a good example of something that you're going to have to know how to do. I've got those charges right there from the periodic table. You need to know how to read the periodic table for those charges, for the oxidation numbers. It's tempting to say, bring down the 2's, but because those subscripts are identical, you always reduce. So the formula is just CaO. And if you think about it, I have a charge of +2 and a charge of -2. So the net charge, the total charge, is 0. It's neutral. So you only need one of each in order to move on. Okay? Okay, for naming covalent compounds, these are pretty easy to name. You are going to have to memorize this list of prefixes. Prefix is what goes out front, of course. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. So just know 1 through 10. And what you do is quite simple. I have P2O3 right here. So I'm going to write out the first element is phosphorus, and then I'm going to look up the prefix 2 is di. So that's where the di comes from. And then the oxygen is, you do the root word. So you do the root word, and then you add "ide." And then again, you have 3 of those, and the prefix for 3 is tri. One thing that you would never do is start with mono. So in this one, we have carbon, and there's only one carbon, and the prefix for mono is, or I'm sorry, the prefix for 1 is mono, but you never ever start with mono because it can lead to kissing. We have oxygen, and the root word, we do the root word and "ide," and there are 2 oxygens, so we say di. Over here we have carbon. Again, notice it does not start with mono. And then we have oxygen with the root word of "ide," and there's only 1, so it is monoxide. Okay, so, and then we use those in reverse to find the formulas. So if I tell you we have triphosphorus, we have phosphorus here. The tri means that the subscript is a 3. And then we have sulfide, which is sulfur. You should be able to see the root word in there. And then the prefix is di because there are 2 of those. Nitrogen monoxide, because it doesn't have a prefix up front, you know it's mono, and there's only 1. And then monoxide is just 1 oxygen. So those should be fairly easy to do. Let me do some practice. So let's do some practice naming here. The first one I see is phosphorus, and the subscript is 4, and the prefix for 4 is tetra. So we have tetra phosphorus, and then I have sulfur, so it's going to be a sulfide, and there's 5, so this is pentasulfide. So these will always end in "ide." Here I have a single nitrogen, so I would normally want to write mononitrogen. However, do not start with mono, so you got to leave that off. And we have 2 oxygens, so it is dioxide. Here I have selenium, and there's only 1, so I'm going to drop the mono. Remember, mono is only dropped for out front. And we have 6 fluorines, and 6 is hexa, and fluorine turns to fluoride. So each of these is just 2 words. We have 2 silicons, so this is disilicon, and bromine turns to bromide, and there are 6, so we say hexabromide. So writing the formulas is pretty easy also. We have the first one is antimony, which is Sb. There's no prefix, so there's only 1. Bromide is bromine, and the tri means that there are, bromine is Br. The tri means that there are 3. So hexaboron, boron is B. Hexa is 6. Monosilicide, silicide is silicon, and there's only 1. We have chlorine dioxide. There's no prefix, so it's just 1 of those. Dioxide means 2 oxygens. We have hydrogen monoiodide. Say that to your friends, right? We have iodine pentafluoride. So these are fairly easy. It's just going to take practice, practice, practice. So I'm going to do this one more time. Like I said, you have to know how to read the periodic table to get the oxidation numbers. Noble gases are 0. They have a full set of valence electrons. Everything in group 1 has 1 valence electron, so it has an oxidation number of 1 plus. Everything in group 2 has 2 plus, and then we skip over the transition metals, and these have 3 plus and 4 plus. Then it's easier to go backwards from here. You have 7 valence electrons in the halogens. The halogens are group 17, so they would gain 1 valence electron, giving them a charge of -1, and then you just count backwards. The only one to really truly memorize, I guess, is that the carbons are a +4, not a -4. So make sure that you know all of this.